It's no secret that Americans love sugar. In order to curb that desire for sweet things, a lot of Americans turn to artificial sweeteners. Of all the artificial sweeteners available, aspartame is probably the most controversial, and that's the topic of today's discussion. So aspartame is a molecule that most of us have heard about. It's the most widely used artificial sweetener. So we're going to do ASW for artificial sweetener. What's interesting about aspartame is that it's 200 times sweeter than sugar or sucrose. We can zoom in here and look at this table. It's from the FDA. We can see aspartame is down here, 200 times sweeter than sucrose, and there's all kinds of other options, some of which I've never heard of, like this one and this one. But I just wanted to give you guys that table to see and to compare to other artificial sweeteners. One of the main things we're going to talk about is if aspartame is a carcinogen or does it cause cancer. There's all sorts of claims in regards to aspartame's safety. This is going to be a big topic of this discussion. This is the structure right here. And if you go over here, the brand name that most people know aspartame by is Equal. I don't really see this artificial sweetener around. And in fact, I really don't see a whole lot of artificial sweeteners around. People still use them. But aspartame is mostly found in diet sodas, diet drinks, chewing gum. We'll talk about that in the next slide. What's interesting about aspartame is that it was, in a way, developed as a replacement for saccharin. And there's a couple reasons why. One of the main reasons is that saccharin is very bitter. If you ever had, I think it's Sweet and Low saccharin. Let's see. Yeah, Sweet and Low. If you've ever had Sweet and Low before, you will know that it's a pretty bitter substance. Personally, I don't really like any artificial sweeteners, but this one is the most egregious because it's pretty bad. If you've never had it, you should try it. The other really unique part about aspartame's discovery is that it was accidental. A lot of discoveries made in science were completely accidental. This one is odd because this guy decided he's doing some research on an anti-ulcer drug, and he decided, let me taste what's on my glove. He tasted it and it tasted sweet, and it went on from there. I don't really know why he decided this was okay, but in his mind it was okay. Now we have aspartame. So let's move on and talk about what we can find aspartame in. So I mentioned that the most common use is in the drinks we consume. So it's in Diet Coke, sugar-free gums, again, Diet Sprite. It is found in some toothpaste brands. I don't think Crest is one of them, but you might be able to find it in some toothpaste brands. A lot of products will have it in there to replace regular sugar. You can find it in artificially sweetened syrups, and like I said, Equal. If you Google what can you find aspartame in, you'll find a long list of things. So I mentioned that Equal was not the main way people consume it. It's really used industrially for all of these purposes. One of the reasons why people choose artificial sweeteners is that they want to add sweetness to something without raising their blood sugar or blood glucose levels. Something I want to talk about briefly is marketing. The food industry does not care about your health. What they care about is money. So what they will do is they will twist and turn some words and phrases to make you think you're making a healthy choice. But like I said, they're just trying to make some money. So you see some of the language going from sugar substitute to a healthy alternative. This is interesting because when I see this type of language, I ask myself a couple of things. Is this really accurate? Is aspartame really a healthy alternative? Then I ask myself, is this helpful? Is this a part of the problem, or is it a solution? But I want to go back to marketing really quickly. We talked about this language these companies use. An interesting point I want to make here is the power of language. Let's change the color here. All of us have heard about Cheerios. I think they're decently tasting. If you look on a Cheerios box, you'll see the American Heart Association supports its consumption as a heart-healthy food. What's interesting is that Cheerios are just pure carbohydrates. And when carbohydrates get metabolized, it is sugar. If you Google this, you compare a bowl of cereal to the same amount of sugar, you'd be surprised how much sugar gets into your bloodstream from carbohydrates. The difference is the time that it takes to get in there. If you're drinking a really sugary drink or eating a really sugary substance, your blood sugar is going to spike quickly. If you consume carbohydrates, it's going to spike after that stuff is processed. I want to make a point here because if you go into the literature, one of the main reasons we have heart disease, in my opinion, is not because of consumption of meats and certain fats, which I think some of that is valid. You see sugar being the culprit. In America, we have a lot of processed foods, processed sugars like high fructose corn syrup. My opinion is that Cheerios are not really heart healthy. This seems to be a ploy, this connection between the medical industry and the food industry. This is an example of the language. We think Cheerios are heart healthy, doesn't have cholesterol, but let's consider the metabolism. It's just sugar. And sugar is not good for anything, especially for your heart. So if we go back to this point, problem versus solution, I think for me, the problem we have in America and other places, but I want to talk about America because that's where I live, is sugar addiction. We love our sugar, and a lot of us are addicted to it. I love sweets, and sometimes I find myself eating too many, and I have to cut back, really cut them out, because I'll just keep eating them. Sugar is pretty addictive. I think until we deal with the sugar addiction, none of this stuff's really going to matter. And even the healthiness of aspartame is up for debate. A point I did want to make is that there's really no data that shows that artificial sweeteners are actually good for those who are obese or those who have diabetes. You would think there are very good studies on this, but there in fact aren't any, well, that I could find. A lot of this information I got from a research paper. It's a few years old, but it was a pretty good amalgamation of a bunch of research studies and data. So to close this slide out, questioning things, especially when it comes to products and things we consume, questioning things is really important. And when it comes to artificial sweeteners, I think these questions are legitimate. But let's get deeper into how these affect our health, specifically aspartame. There's a lot of controversy involved. I mentioned earlier that there are a lot of concerns regarding aspartame safety. The paper I read discussed a bunch of them. I'm only going to discuss a few that I found interesting. The claims are it's neurotoxic, causes behavior problems, causes headaches, depression, ADHD, autism, and mood disorders. I want to walk you guys through some of the science behind why people may say these things. So we have aspartame right here. This will metabolize into aspartic acid. It also metabolizes into something called phenylalanine. and this will turn into something called tyrosine. We're going to talk about that in a second. Aspartic acid will turn into methanol, which is alcohol, a type of alcohol. Here is one of the points people make. Methanol can poison a fetus if it's consumed in a certain amount. This can cause things like developmental delays, retardation, and other things. A lot of this affects the brain. So although the idea here is that methanol can poison the fetus, just because you consume aspartame and it turns into methanol does not mean that you'll poison the fetus, but this is the idea. Also, methanol will turn into formaldehyde. We're going to talk about that in the next slide. Formaldehyde is a carcinogen. It is cancer-causing. It will react with DNA and RNA. These products, plus certain proteins, have been shown to reflect similar changes in the brain as someone with autism. In '83, I believe, autism really spiked in America, and it's spiking more and more and more. So the big question has been, what is causing this spike? And as you guys know, there are so many different theories people have regarding why autism started blowing up so quickly. And this is one of the many things. So let's continue. Another piece is these mood disorders. So something that science knows that we're aware of is that we have these neurotransmitters. In this case, we have norepinephrine, I don't want to spell all of it, and dopamine. These neurotransmitters are known to really be very functional in regards to mood, cognition, learning, all sorts of different things. It's very, very important. We also know that phenylalanine, I'll just put PHY, tryptophan, and tyrosine are incredibly important molecules because these will help synthesize or create norepinephrine, dopamine, and another one called serotonin. And some of us may know of these. They're very important molecules. So why am I talking about these? Well, it turns out that aspartame will metabolize into phenylalanine. We've talked about that. Increased phenylalanine levels inhibit or greatly slow down these enzymes. Now, tyrosine and tryptophan have these enzymes that will help to make dopamine and serotonin. I'm just going to put an S there. If these enzymes are inhibited or their function is reduced, you will have less dopamine and less serotonin. You won't synthesize as much. Since dopamine, serotonin, all these neurotransmitters are associated with mood and learning, then the idea is that if you're consuming aspartame, your mood can be thrown off and the way you process information can be thrown off. As we can see here, just like the last points I made, just because this flows the way it does doesn't mean you can directly link aspartame to low mood or, as I mentioned, developmental delays and things like that. I just want to show you guys some of the ideas behind why this could be an issue. In my opinion, this is not the most concerning piece. The most concerning piece is cancer. We'll talk about that in a second. But I do want to mention something called phenylketonuria. I'm not going to spell it all out. All this is a lack of ability for the body to metabolize phenylalanine. So usually you have this enzyme that will convert phenylalanine to tyrosine. We just talked about that over here. We mentioned it briefly. This is very important. I mentioned that any molecule we have in our body has to be broken down, has to be produced. There's a constant give and take. If phenylalanine builds up in the brain, it can cause intellectual disabilities. It can cause motor delays and something called microcephaly, which is a small skull. If you Google that, you'll see that. PKU, it's important to understand what this is, because if you consume aspartame, the amount of phenylalanine in your blood will increase by a lot. And if you have PKU and you can't break that down, it'll build up and it can cause all sorts of different problems. There are a lot of factors involved, like how much, what your biology is like, but overall, it's always suggested that if you have PKU, you do not consume products with aspartame in them. So let's talk about, in my opinion, the most important piece in regards to aspartame's safety, and this is the possible risk of cancer. Okay, so this is a very interesting piece. First of all, I want to mention this. This molecule is part of this group called 2B. There are a list of carcinogens. Everything that we consume is on a spectrum from not carcinogenic to possibly carcinogenic to carcinogenic. And there's a bunch of other little things. Regardless of that, this is group 2B, which is possibly carcinogenic. I don't know about you, but this is concerning to me. This is not, there's a big difference between not carcinogenic and possibly. I do not want to consume something that's possibly carcinogenic. Now, there's a lot of things in 2B, but I think this is important to know. So let's dig into this. So the recommended dietary intake of formaldehyde is about 0.15 milligrams per kilogram. 1 liter of diet soda has about 600 milligrams of aspartame, which converts into about 60 milligrams of formaldehyde. So why is this an issue? Well, if you're 135 pounds, this means you're about 61 kilograms. This means that according to the recommended daily intake, you should be consuming about 9.15 milligrams of aspartame of formaldehyde given your body weight. The issue here is that 1 liter of diet soda is 60 milligrams of formaldehyde. That's like 6 to 7 times more than the recommended daily intake. That's pretty concerning. But let's talk about some of the research data available in regards to whether or not this stuff can cause cancer. So first of all, I want to make a little legend or a little reference. We're going to be talking about cell death. Okay, we're going to make a couple mentions about it. These things called oncogenes. These things called tumor suppressor genes. And the cell cycle. This is not going to be a class. I just want to give you guys some points here. So in the first little study that was done, they studied it in these things called HeLa cells. These pretty much immortal cells that kind of divide and divide and divide. They saw that aspartame did not cause any death of the cells, but what it did do is that it rose the amount of something called the HCl2 gene. Now, what is that? This is a gene that regulates cell death. We're going to put CD. Then it decreases the p53 gene. This gene is a tumor suppressor gene. So this is a really important gene in biology because as cells grow, divide, and die, you need mechanisms involved to hold up cell growth. And this is one of those. So why is this important? Well, the HCl2 gene regulates cell death. So if you increase the amount of the HCl2 gene, it can cause issues with the natural process of cells dying. The p53 gene, if you decrease the tumor suppression, then you could have an increase in cell division, which could result in tumors. One other thing I wanted to mention that I didn't mention is the Bax gene. This is a decrease of Bax gene, and this regulates cell death. So as far as the HeLa cells, it's not looking too good in regards to aspartame. But like anything, although this is a human cell line, and it seems like a pretty decent study, there's a lot more involved in this. You can't really make any claims off of this, but it's important. Then they did a study on mice. These mice were 5 weeks old. What they found was that it increased the amount of 2 oncogenes. So what is an oncogene? An oncogene is a gene that has the potential to cause cancer. It also increased p53. We just mentioned that p53 is tumor suppression. So this is good, at least for this argument. It increases the amount of tumor suppression. So we're seeing a negative and a positive. So that's very interesting there. Now, I want to mention this. This point I'm going to make is why this study doesn't really work. As far as the amount they gave these mice, it was about 200 milligrams per kilogram. Now, if we use our example of the 61 kilogram person, you would have to consume about 12,200 milligrams of aspartame to even replicate these results. In other words, about 20 liters of diet soda. There are people that will put down a whole liter a day. Not good for you, but I want to show you the scale. It's just very, very difficult to replicate. Then they studied some rats from prenatal to death. They found that aspartame could have a carcinogenic effect in the young. And in the liver, they found a couple things. An increase in something called P27. Now this will halt the cell cycle. This is important because when cells are going through that cell cycle and they're dividing and they're getting their assignments and things like that, you need genes to pause the cell cycle to regulate things. So as far as this argument, it's pretty good. But they also saw an increase of something called HRAS. And HRAS is an oncogene. This could cause cancer. Again, we have an interesting situation. We have an increase of a gene that, in this case, is a little beneficial, and an increase in a gene that's not beneficial at all. But what's more important is that we have a treatment versus control. The treatment group got aspartame. So this is what we want to look at, this treatment group. What they found was in the treatment group, you had actually a greater decrease in P27 than versus the control. We talked about how P27 halts the cell cycle. Well, if you decrease it, that means those mechanisms involved in halting the cell cycle aren't functioning properly, which could result in an overproduction of cells, which could cause cancer. And then one other piece, this is very, very loose, but The study showed that there is a higher ADH activity in men with non-Hodgkin's lymphoma and multiple myeloma. ADH is what is used to process aspartame. So because there's higher ADH activity in these cancers, and there's a high ADH activity in aspartame metabolism, then they say that aspartame in some way is related loosely to these types of cancers. This is a really interesting point. I just want to bring it in here. It's just very loose. But as you can see with all these little studies, you can see how it's possibly carcinogenic, because at least in the lab, they can show that there is potential for cancer, but you cannot conclusively say it causes cancer. So let's go through the summary and review what we learned. So we started out talking about how aspartame is the most widely used artificial sweetener, if not one of the most. It's a lot sweeter than regular sugar, and it's possibly a carcinogen. And it was discovered on accident by some guy just tasting what was on his glove. And now we have aspartame. And then we just went over how aspartame is mostly found in like diet drinks, diet food items like syrups and gums. We then spoke about obesity and diabetes. You mentioned that there's not really any studies that show that it's good for obesity and diabetes. But the biggest thing I mentioned is marketing. It's so interesting how these companies use marketing to make you feel like you're making healthier choices, but are you really? It's also important to mention that some of this stuff is up for debate, a little controversial, but my point about the food industry, I think, is important in regards to this conversation. Then we got into the quote-unquote risks that some people say aspartame can present. Talked about aspartame's metabolism, how this, at least from these mechanisms, might result in poisoning of the fetus or a carcinogenic-like effect from formaldehyde. We talked about the possible effect it has on mood, given what we know about increased phenylalanine levels and their effect on neurotransmitters. But I did mention that none of this is conclusive. It's all highly correlational, not causational. And then we briefly mentioned PKU and how if you have PKU, you shouldn't be consuming anything with aspartame in it because it dramatically increases the phenylalanine levels in the brain. And then lastly, we talked about the cancer-causing effect, the possible cancer-causing effect. We talked about formaldehyde, how, if you consume a liter of diet soda, you're consuming way more formaldehyde than you should. We spoke about all these little studies that, although they are not conclusive whatsoever in that possibility that it could cause cancer, we saw that there are pieces to this data that at least lead us to say that it is possibly carcinogenic. It does increase the presence of some oncogenes. It does decrease the presence of some tumor suppressor genes and things like that. I hope you guys learned a lot. This was a very interesting video for me to make. I didn't really know much about aspartame, but I feel a lot more educated now. I hope you guys feel the same way. So as always, thank you so much for watching and listening. Please like, comment, and subscribe. Tell your friends, and I'll be back soon with another video.